Hi everyone, good morning. So my name is Vamshi Krishna, and I prepared a short demo to cover my research topic titled "Semi-Supervised Ensemble Approaches for Parts of Switch Tagging." Mainly, we did all our experiments on the resource-poor languages. So going through the contents of the demo, first I'll give a brief. Uh, Brief introduction to all the problems we attempted, and then go through the background studies we had to do for it, and then like the publications and the challenges sections, and then finally I'll end this demo with the technical details and a proposed thesis outline. So coming to the problems we explored. So when I came to know about this random forest ensemble algorithm, so I wanted to deep dive and understand more about why why selecting a decision from the randomly selected subset of data performs better than a single decision tree. So I started exploring more about this and want to understand in depth. And then in that process, I tried to even I wanted to come up with a decision tree, uh, which where we can use a decision tree where we can use a different selection measures basing on the depth of the level of the tree. Like in the top level we can use one kind of selection measures, and in the middle part of the tree we can come up with we can use different measures, and in the last leaf nodes we can use another measure. So basically a dynamic way of selecting measures basing on the depth of the tree. And then even I worked on coming up with a new way of selecting k nearest neighbors in kn by dividing the entire feature set space into multiple dimensional planes and select a single point in each of the plane. Like to give a good example, like if we have just a two feature set data set, so we can we want to label a test instance, so we can divide the entire feature set by dividing by drawing two axes, and selecting each point in each of the quadrants. So in the similar way we were exploring how we can standardize this approach for n features. And then after all this various experiments, did a performance study of ensemble all the ensemble algorithms, mainly focusing on the selection stage where how we can select uh, a subset of classifiers from the base classifiers depending upon the point depending upon the characteristics of the test instance we want to label. So there are mainly three phases in the ensemble: generation, selection, and integration. So I did a performance study in the second phase of selection, the second phase selection. So continuing the performance studies, so from all the applications, I noticed parts of speech tagging algorithms are more complementary, to each other. So some of the post tagging algorithms, which were considered like SVM tool, context based list post tagging algorithm, CRF, and Stanford. So what we noticed is post tagging algorithms have are complementary to each have complementary characteristics, and we want to explore ensemble approaches, and that's the reason we want to explore ensemble approaches in POS tagging. And then also as in this direction, the first step we did was uh, how we can enhance the supervised taggers with the help of semi-supervised taggers using a static decision tree ensemble. And following the static approach, we came up with a dynamic selection, classical selection, by expressing the each words in a vector shape using word to vec, and then finding the effective competence region and selecting the classifiers which perform better in this competence region. So these are some of the experiments we did for ensemble approaches of POS tagging. And to this is the thesis motivation is to study the ensemble approaches and the performance differences with the change of data sizes, uh, with change of input data sizes. And what we noticed is like there was minimal studies on the dynamic classifier selection approaches in post tagging, and that's what we took an advantage and proposed the approaches in DCS. And our main area of focus is to not to build a state of the art power taggers for any language, but to further explore the ensemble approaches in post tagging. And like the background studies we had to do as part of this research work is like we were exploring what all various classified generation methods which are used for ensemble approaches, like using different classifiers, different training sets, or different feature sets, and also the same classifier with the different parameters, like all these various ways of generating different classifiers. And then comes the selection phase, where we have to either where there are mainly two approaches, static and dynamic ways of selecting from the base classifiers, and then the aggregation where non-trainable, which are more like a simple majority voting algorithm, or trainable where we apply a second layer of classification on the outputs of the base classifiers, and then a dynamic weighting where we give dynamic weight to each of the base classifiers basing on the performance in the competence region. So this is the background study we have to do, and some of the related work already in this field. I'm highlighting only the ensemble approaches for post tagging. So this is one of the paper which motivated us to do this work, where it's a semi-supervised condensed nearest neighbor approach, where they combine a supervised SVM tool and unsupervised post tagging method with the help of a decision tree to improve the accuracy on top of the base classifiers. And there is also ensemble approaches for European and Chinese languages. So coming to the publications, we have one publication titled Decision Tree Ensemble for Parts of Speech Tagging of Resource Poor Languages, which is published at Forum for Information Retrieval Evaluation File 2018. And the main challenges we faced during our research work was like I was constantly a constant switching between various research statement and to finalize the exact thesis problem statement, and then like implementing the experiments of other published papers to produce the similar results. And like this is the common step, data collection and pre-processing, where it's not like a major challenge. And the other challenge where we faced to publish this result, it's like it's only comparable with the state of the art post tagging algorithms, but when we use a very less data set for comparison, like say for example we used only 10K labeled and 30K unlabeled uh, unlabeled data sizes. And this is our experiments. Sorry for that. So this is our experiment. So we did our experiments over five Indian languages, and we can see, like for example, if we can see Bengali is so the CRF based and the context based are like having 58 and 47 accuracies, whereas our dynamic classifier selection improved on top of this base classifiers, and also decision tree is also better than the base classifiers. And the oracle accuracy is the accuracy where even if one of the base classifiers is labeled as a correct, this is the maximum accuracy like we can reach from this base classifiers. So for very less data sizes we can show a significant improvement, but as we increase the like labeled data, there are not significant improvements. So coming to the technical details, this is how our our ensemble classifier works for a decision tree based, like where we have a annotated and untrained untagged data sets, where we create base classifiers with the combination of these two annotated and unannotated data sets, and then we transform each word into features which are basically outputs of this base classifiers, and then we apply a decision tree algorithm with the transformed data set. So this is how our like setup looks for a ensemble approach. And coming to the dynamic classifier selection methods, where for a given first stage, assuming first stage is already done, where we generate multiple classifiers. So for a given test instance, we have to we come up with a neighborhood competence region. And as we in this DS dynamic classifier methods, so as we used word to vec to convert each word into a vector space, and we use Euclidean distance to find out the nearest neighbors, and then we evaluate the classifiers present in this neighborhood region, and we only selected few classifiers which are performing better, which have better accuracy in this competence region. And then for the final labeling of this test instance, we use only these classifiers. Combining everything, this is how the thesis outline looked like, where the first approach would be the like a decision tree approach, and the second approach is a dynamic classifier selection approach to combine supervised and supervised taggers. So one thing we can we can tell is that in both we used only labeled and unlabeled data for training, and not domain based features. So this makes like a supervised ensembles and idea for